College has taught you everything about resistors, except how to actually buy one, which we are going to talk about right now. So we're mainly concerned about surface mount resistors. That's what we do in a modern design. For ye olde designs, you'll see that they did all through hole, because that's all they had at the time. But there is some specialized features here, but I've never had to go into these. Chassis mount resistors, that's if you need a high power rating, and it's connected to either a chassis like it implies or a heatsink. Adjustable power resistors, this can really help if you're trying to during prototype phase. So when you need high power, also they make a good clink when you do that. So, but mainly in a modern design, we're going to be looking at surface mount right here, which is right here. So to speed things along on Digi-Key, I've already selected a few things. Product status must be active. I don't want obsolete. The resistance value we're going to look at is just a regular 10K resistor, not a big deal. Stocking options must be in stock, because if I can't buy it, then it does me no good. So if we just look at that in general, we see, also, I organize by quantity available. I ain't going to buy something where there's only one or two available. In this case, millions. So we see different sizes here, 0402s, 0603s, 0201s. So, and you'll see these predominantly are about 1%ers. So you see that right here. 1% seems to dominate, a few 5%ers. Well, that's what we'd like. Okay, so to go through all this stuff, your tolerance, you should be calculating how the low end and the high end of the tolerance affects your circuit. So by doing the math, you will know what you actually need for tolerance. And the same applies for power. P equals I squared R. So if you know your current, you know this resistance, you can calculate power, so you will know what power rating you need. Now, these features here, for the most part, you won't need. I won't say you don't need them for sure, depending on what industry you're in. Just, I have never found the need to go out of my way for most of these. Anti-corrosive, dude, my company makes products where there's corrosive compounds, and we've never gone out of our way to do anti-corrosive resistors. Same goes with anti-sulfur. Now, for automotive, though, now, my company is not in the car industry, but I still go out of my way to approve at least one resistor or component in general that is automotive qualified. And that's because I learned the hard way through COVID and all the supply chain issues is that your normal stuff, when you can't get it, you can probably still get the automotive qualified components. So they're going to cost more, but during those days, it was either pay for the automotive or don't sell the product. That makes the decision pretty easy. Current sense, high voltage, all that stuff. You will know if you need it. So same thing with military. Moisture resistant. No, I've never gone my way for a special moisture resistant resistor. They're pretty good as is. So the one I have gone out of my way to do is pulse withstanding. Just because, imagine you have a resistor connected to an AC voltage line. You know, you have some pretty large pulses there. So I don't want a resistor to burn up when it's connected to an AC voltage line. That just screams like a big safety issue, which no, I don't want to deal with. So next we're going to talk about temperature coefficient a little bit later. So, and then you have packaging case. So this is has to deal with the physical dimensions of the resistor itself. So what I particularly do is when I have a choice, sometimes your company may standardize on a particular size. unless requirements have you do something else. I do 0603. This is despite the fact that even the cheapest vendors this day and age can do 0402s without a cost adder. I do 0603 because it's a good balance. One, it's small enough that you can have a dense design, and it's still big enough that if you mess up, then on your prototype, you can easily take the component off and put a new one on. For 0402 and smaller, it's a pain in the ass, and I just don't want to deal with it. So we're going to look at 0603 right here. If we go down here, still millions available. 1%ers still dominate. And then you do have some of the fancy features here. So what we're going to look into is an actual data sheet of this guy right here. The resistor itself is nothing special, but these guys, Vishay, they have better data sheets. That's the only reason why I'm choosing them. So if we go here, we see right off the bat my favorite word, standard. I don't want to pick some weirdo esoteric thing. So, but what I always tell the entry mid-levels, and sometimes the seniors need to hear this also. So just be boring. Boring has all the advantages in the world. For this, it's inexpensive and easy to get. And if this particular one would go obsolete, there's plenty more out there to replace it with. So standard is good. So we'll see in a resistor data sheet here, this encompasses many different values, many different sizes here. So that's normal. Resistance tolerance for this family is either 5% or 1%. As we just shown, 1% is what you should be targeting this day and age, unless you have a reason for a tighter tolerance. So for temperature coefficient, so it's either 200 ppm per degree Kelvin or 100. So your resistance can vary a little bit based off temperature. So we're going to go into this white paper here, temperature coefficient of resistance for current sensing. For what we're doing, I don't care about the current sensing part. So they just had nice graphs down below. So I did note copper using terminations is approximately 3,900 ppm. That's parts per million, by the way. So I'm like, wow, that's a lot more than 100 we saw for that resistor. So the reason I wanted this paper right here is a couple reasons. One, we've got formulas right here to calculate your final resistance based off temperature. Second off, this graph already has 100 ppm, which is what we saw. So if your resistor, not ambient, temperature of the resistor itself is at 125 C, it's going to be plus or minus 1%. This is in addition to the 1% tolerance. So 1% plus 1% means maximum of 2%. So I'm assuming that with the 500 ppm, this is ye olde stuff right here. Otherwise, they won't include it. This day and age, no, you don't really get up to this 500 range for anything modern that you would be doing. But just remember, it was a thing. And for older designs, it may still be a thing you need to worry about. But by and large, not really. So let's go back to our data sheet right here. So now we have power ratings right here. You'll notice in this data sheet, it says, hey, 0.1%, but a lot of the industry just says 10th watt, 8th watt, quarter watt, half watt, 1 watt, and so on. So once again, you can calculate this. You should know what your power dissipation requirements are for your resistors. Only other thing I'll note is that for 2512 resistors, you can also get them that can go in like 2 or 3 watts pretty easily. So something to keep in mind there. Now, this next one, nobody talks about this one, but it can get you. And this is the operating voltage of these resistors. So this is completely different than the power rating. This is a voltage rating that is independent of the power rating. So one time, for years, I didn't go into a resistor data sheet at all, just because what you see here, good enough for most cases. But I did have a case where we were dealing with very high voltages, 6,000 volts. So when they tried to switch a resistor in the design, they wanted me to check it. So they were not even close. So they thought they could just do a regular old resistor. That's when I finally went into these data sheets and said, all right, what's going on here? And that is why it has compelled me to make this video. All right, now, temperature range. This isn't the whole story. Let's scroll down a bit to look at the graphs. So always nice when a data sheet includes some kind of product matrix. That way I can decipher their part numbers. It's to the point where if they don't have this, I'm going to really think about whether I want to use that part or not. But anyways, we want to go down to the graphs. So single pulse, continuous pulse. So, and then pulse load measured in watts. So like this 2512, 1 watt at nominal. But if your pulse is short enough, you can go much, much higher. So same thing with continuous pulse. Okay, now pulse voltage here, you notice your 2512s and 2010s are way above the rest. So you may need to know this, particularly if you're dealing with AC voltage. So this right here is why sometimes I do go with pulse rated, because it'll be much higher than this. So this is something to keep in mind. And then power dissipation. So you'll notice at ambient temperature, at 70 degrees C and lower, you will be able to hit the rated wattage of your resistor. But beyond that, it gets derated. So please keep that in mind depending on your application, especially if it's used outdoors during the summer. And your case happens to be black and it's in full sun. So something to keep in mind, power rating is not for all temperatures. It does get derated at some point. Okay, nonlinearity here. So there's going to be some distortion in a resistor. So we're assuming for here, like imagine a perfect sine wave. So there's going to be some distortion here in the third harmonic. So we did 0603 10K. That gets you close enough to 60 dB. You do the math, that ends up being a 0.1% distortion. So for the most part, don't care. For the hardcore analog guys, yeah, that might matter. Same thing here with noise. Just from a pure technical point of view, your resistors can be a noise source. So, okay, how much? Well, 10K 0603, we're at 2 microvolts per volt. So if we have 5 volts across that resistor, we're going to have 10 microvolts worth of noise. Once again, for most applications, that is way too small for me to care about. But for the hardcore analog guys, maybe the audio guys, this is of interest. So you want to keep that in mind. So everything else in this data sheet here is compliance stuff. Dude, if you really want to know about resistors and such, yeah, you can do that. Solder pad recommendations. But once again, we're dealing with standard resistors here. That means with a standard size. So like if you already have a footprint, you're probably good to go. So that's it. I want to go through this just because nobody went through it for me. And because there were some specs here that I had no idea about. And it can throw you for a loop. So thank you for your time. Have a good one and see you in the next video.